So Jordan and I are out here again. This is our research lab. Jordan's just typing away on the calculator. We've been here all day, kind of trapped. Apparently there's some pretty aggressive quintic functions out there. We should be safe in here. Nothing that we won't be able to handle though. So log number 1. Peace out. You can see here these are all the quintic functions that we've been researching so far. They've all been pretty good to us. Not too crazy, they can get a little out of hand, but for the most part it's been alright. It's been alright. Oh my gosh, Jordan. Well, everybody watching, Jordan and I just came across one of the craziest quintic functions I've ever seen in my life.
Me too. Oh my, I've never seen anything like it.
It's something out of the ordinary. At first we didn't even think it was a quintic function. We were maybe thinking that could be quartic or I don't even know, but you have to check this one out.
Alright, analyzing our quintic function here, we can look further and try and analyze our long-run behavior as well as limit notation. So first of all, for a long-run behavior, it essentially means where is the function heading to infinity as well as negative infinity. So looking from as x goes to infinity, f of x is going to positive infinity, and as x is going to negative infinity, f of x is going to negative infinity as well. And now looking at our limit notation, as x approaches 2 from the left, f of x is 0 from the positive, and as x approaches 2 from the right, f of x is 0 from the negative.
So for this section of our investigation, we were looking into the degree and the turning points of this quintic function. So at first glance, Jordan and I had seen this function and all of the different exponents and thought, what could this be? But after adding up these exponents, we did come to the conclusion that it was truly the quintic function that we were searching for in this hot desert. And so next we decided to investigate the turning points. And so after taking a couple pictures of the function in the wild, we took a picture from this angle and we saw the function in a new light, almost graphed. And so we looked here at the function, its behavior, and we saw that there were turning points both there, and we came to the conclusion that there were 2 turning points in this function. So, looking at the equation of our quintic function, we determined what values of x created or determined the function to be 0 overall. So for example, in this first one, if x were to be positive 2, subtract 2, there is 0.
And then looking at our graph here of our function, you can see one of our zeros is at 1.5, so we got that from this 2x minus 3, and that has an exponent of 1, so you can see how it just goes straight through the x-axis. And then for x minus 2, like we said, x plus 2 is where the equation would be set to 0, so you got another intercept there that also goes straight through. And then lastly at x minus 3, so it would be positive 3, and because it's cubic exponent, that's why we've got that weird kind of how it goes through the x-axis. So that's our x-intercepts for our quintic function.
It's a cheeky little bugger, if I may say, Jordan.
That's right. Nice. Okay, next we're going to be analyzing the instantaneous rate of change of our function. So first I'll start with our positive IROC, and we're looking at the point 3.5. So on our graph here, it'd be that point right there. And so plugging it into the equation, looking at f at 3.5 plus 0.001 minus f at 3.5 over 3.5 plus 0.001 minus 3.5, eventually we get to the answer that 3.5 has a positive instantaneous rate of change of 0.5.
So with this new quintic function that we've never really seen before out in the Safari, we decided to dig a little deeper than just our positive AROC. We decided to investigate the negative IROC, which is something that we've never really seen before in these quintic functions. So to calculate, I first picked 2 points, so 2 and 2.0001, plug them into this equation here of f of b minus f of a over b minus a. So I plugged b in there to be f f of 2.001, and then a for negative f over 2, once again over b minus a, so 2.001 minus 2, which gave me, well, since we can see here that f of 2 is equal to 0, that it basically cancels itself out because anything minus 0 is just that number itself. And so we decided to keep it as f of 2.0001 because the actual number, like when solved and plugged into this equation, was pretty gross. And so we decided to keep it simpler, and when calculating, if you keep it in this form in your calculator, you get more of a direct answer. And so our final answer for like the instantaneous rate of change was approximately negative 0.99, proving that the instantaneous rate of change between the points 2 and 2.001 is negative. Jordan, Braden here. We're in the safari of Appleby College, and we're investigating some quintic functions and also just some crazy beasts. So we're gonna be going out and looking at some right now. How do I turn it around? Do you know how to turn the camera?
I don't think you can if it's already.
Uh-oh. Well, look at that. We're gonna have to go like this. Dun, 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 dun. There's one in general that we're looking for. Never before been seen.
I think it's somewhere over there.
Somewhere down the end of the corridor. Wow, it's hard being out in the heat for this long.
Oh, it is hot.
I'm getting pretty restless.
Oh, I think I see something in there.
Look at that. You can't zoom in. I'm gonna try and get close to it.
Okay, be quiet.
I'm gonna try and touch it. That was crazy, Jordan. Oh, we just put our lives in danger. Oh my gosh, okay. We're out for now.
We made it out safely.